Every evening I spend a few hours out here in my workshop, filming videos, designing parts, editing, or just working on projects. It's only about 3 by 4.5 meters, and because I don't want dust blowing in and I'm often filming, I normally keep the door and windows shut. But recently that had me wondering, what's actually happening to the air in here? There's printers, dust, and fumes, or is there something else I should be worrying about? So over the past week I've been measuring the air quality, and the results weren't quite what I expected. Networked Artifacts recently sent me one of their AirLab air quality monitors. Rather than doing a traditional review where I spend 10 minutes talking through specifications, I thought it'd be more interesting to actually use it to answer a few questions I had about my workshop. The AirLab measures a range of metrics, including temperature, humidity, carbon dioxide, volatile organic compounds, nitrogen oxides, and pressure, and it continuously logs all of that data over time. That logging is the really important feature here, because instead of looking at just one measurement, we can actually see how the environment changes over the entire evening. So I set up 3 different tests, each running for 2 hours in the evening. First I wanted to establish a baseline. What does the workshop actually look like when nothing's happening? So I left the monitor running for an evening with no printers and nobody working inside. As you'd expect, everything stayed pretty stable. CO2 stayed around an average of just over 500 ppm. Temperature slowly dropped through the evening and humidity increased. VOCs stabilized because I moved the AirLab into my workshop and then trended towards an average of 100. And NOx didn't have any notable change. So nothing particularly surprising here, but this gives us a useful reference point before we start changing things. The next question was one I've seen discussed online countless times. What effect do 3D printers actually have on the air quality? To find out, I loaded all 3 printers with roughly 2-hour prints. I closed everything up and then let the AirLab continuously record what happened. This wasn't intended to be a lab test, it's simply a representation of a typical evening in my workshop, and within the capabilities of the AirLab sensors. It would have been great if it had a PM2.5 sensor too, but perhaps that can be a follow-up video. After 2 hours of printing, the results were somewhat unexpected. I only really print in PLA and PETG, which are considered cleaner filaments, but I didn't expect there to be hardly any change over time. CO2 was similar to the previous evening, this time just under 500 ppm. Temperature and humidity looked similar to the previous evening too. Despite the printers dumping heat into the workshop, it's quite poorly insulated, as you can see from the ambient temperature. So the temperature doesn't increase over the 2-hour period. The most interesting is VOCs. I expected this graph to slowly trend upwards. Instead, there's hardly any change. It looks almost identical to the previous evening. NOx is again expectedly uneventful, as printers don't give off any nitrogen oxides. This is usually increased by burning fossil fuels. But interestingly, as I discovered working in my workshop on the 3rd evening, the printers weren't actually the biggest issue. I was. Carbon dioxide steadily climbed throughout the evening. This room only has a volume of around 32 cubic meters. With the windows closed and me sitting in here for a couple of hours, I was gradually replacing the fresh air with exhaled carbon dioxide. Over the evening, it climbed to just under 2,000 parts per million. As a rough guide, clean outdoor air is around 400 to 500. Good indoor air is under 1,000, and anything over that could do with some ventilation improvement. Over 1,500 you'll start noticing signs of fatigue and sleepiness, and over 2,000 you may experience headaches and drowsiness. So an increase to over 1,800 in only 2 hours, with just me in the workshop, is quite bad. Once I saw this graph, it made sense why after editing for a few hours, I'd sometimes walk back to the house feeling a little bit sluggish. So now I had a problem. I clearly needed more fresh air, and the obvious answer is simply opening up a window. But that creates other problems: dust, noise, and rain. What I really wanted was filtered fresh air entering the workshop automatically whenever it was actually needed. So naturally, I opened up Fusion and started designing this ventilation system. On the outside is a rain hood to stop water entering. Behind that we got a removable filter which uses inexpensive air conditioning filter media, and this catches most of the dust. Then 5 140mm Arctic fans draw the filtered outside air into the workshop. The whole assembly is designed to slot into my open window tracks and seal off any gaps around the fans. The whole assembly is 3D printed from PETG, so it'll happily survive being partially outdoors. I had to split it up quite a bit to allow it to be printed on the bed of my printers. The parts then all screw together using a combination of brass inserts and M3 button head screws. Internally, I've cut a section of air conditioning filter which sits between the rain hood and the fans, and this is held in place with some 3D printed retainers. Behind that sits the 5 fans. I bought a 5-pack of Arctic P14 PWM fans, which should be good for the pressure restriction that the filter media creates. This leads me to my next design addition. I don't want the 5 fans running flat out continuously. Most of the time the air quality in my workshop is perfectly fine. So instead of building a simple fan system, why not use the AirLab to make it smart? One of the nice things about the AirLab is that it's got some GPIO pins. These can be configured as PWM output pins, which is perfect to control the fans. The AirLab is open source, so you can edit or write your own firmware for it to use these pins to add the functionality. But they've also cleverly included an option to create and run your own plugins right on the device. So I wrote a custom plugin that continuously monitors the sensor data and automatically adjusts the fan speed on the stack accordingly. If CO2 starts climbing, the fans slowly increase over 4 different levels. Similarly, if VOCs, NOx or temperature increase, then so does the airflow. The workshop effectively ventilates itself only when it actually needs to, and the rest of the time the fans are off. Of course, nothing works perfectly the first time. I connected the fan up and nothing happened. It just ran at full speed even when the AirLab said it should be off or at low speed. So out came the oscilloscope. It turns out I had set the PWM frequency to 25 kHz. This is ideal for the fans I'm using, but it seems it might be out of the range that the ESP32 in the AirLab can produce. So it just outputed nothing. After a few iterations, I reduced the frequency to 10 kHz. This seemed to then work on the AirLab and the fans were happy with it. So now I can get this fan reinstalled and try it out. The fans now spin up when CO2 increases and automatically stop when it comes back down again. Now for the real test. I repeated the same 2-hour work experiment the following evening, but this time with the automatic ventilation running. And the difference was immediately obvious. Instead of continuously climbing, the fans ramp up automatically, fresh air is brought in, and the CO2 level stabilizes at a much healthier level. Better yet, when I'm not in here, or if I'm only in here briefly, then the fans simply stop. This actually turned out to be a much more interesting project than I expected. I originally set out just to see what was happening to the air in my workshop. Instead, I discovered that the biggest issue wasn't the printers, as I had thought, it was simply me spending hours in a small sealed up room. Now the workshop monitors itself, logs everything continuously, and automatically brings in fresh filtered air whenever it needs to. Best of all, because it's driven directly from the AirLab, I can keep extending it with additional logic, or I can change parameters as I think of new ideas. They even have an integration with Home Assistant. I'll publish the fan enclosure files along with the AirLab plugin on my blog, so if anyone else wants to build something similar for their own workshop or makerspace, be sure to check that out. As always, please remember to like this video if you enjoyed it, and subscribe for more tech and electronics projects, tutorials and reviews.